Okay, section 7.5b, we're continuing to solve radical equations, and this time we have rational exponent equations. So you can see a variable raised to an exponent, which in this case happens to be a fraction. So to solve these, you are going to raise it to the power that is the reciprocal of the fraction you see. So for 1/3, the reciprocal of that would be 3 over 1. So then you have to do that to both sides. So you'd be taking 9 to the 3rd power. If you don't know that by heart and you need to use your calculator, that is okay. Do 9 to the 3rd power. And we see that that equals 729. So x equals 9 to the 3rd power. X equals 729. For our second example, we have 3 times x to the 3/5 power equals 81. Now, when we had rationals previously, the first thing we said was we had to get the square root by itself. So in this case, we have to get the exponent by itself. So we're going to get rid of that 3. Since it's multiplication, we're going to divide both sides by 3. So now we have x to the 3/5 equals, and we do 81 divided by 3, which is 27. Now, just like the last problem, we have the exponent by itself. We're going to multiply by that reciprocal, 5/3. So we're going to raise 27 to the 5/3 power. Again, you can use your calculator. And we're plugging in 27 to the, we want to use a parentheses, 5/3 power, which gives us 243. So x equals 243. Now for example 3, even though we have something in parentheses, we have that raised to a power. So technically, what's being raised to the power is that binomial x minus 5. So we're already at the stage where we want to multiply by the reciprocal. So x minus 5 equals 3 to the 3rd power, which if you use your calculator is 27. Then we just have another one step to this equation. X equals 32. For number 4, the exponent's by itself, so we jump right to raising it to the reciprocal power. So x equals 9 to the 3/2 power. And again, we're not making you spend all night working that out. So 9 raised to the 3/2 power equals 27. For example 5, we have a couple of steps involved here because we have a 2 in front of that binomial. We want to get rid of that first because we want whatever's being raised to the exponent by itself. So now we have x minus 2 to the 2/3 power equals 25. Then we do that same thing. What's our reciprocal? And we raise it to that power. And again, we can just look at our calculator for that. So we were looking at 25.
Jennifer Boulevard.
So for this problem, we're taking 25 to the 3/2 power. And that gives us 125. So x minus 2 equals 125, and we're not done. So we have to add 2 to both sides, so x equals 127. For the next example, we have x's on both sides, and they're both raised to powers. And we need to make both fractions disappear. If we were to raise it to the 2nd power, it would get rid of the exponent on one side, but not on the other side. So we're actually going to raise this to the fourth power to make sure that we can get rid of the exponent. Okay, we have a slight change to example 6. They both should be raised to the 1/2 power, which in that case we multiply both sides by the reciprocal. That gives us 2x plus 1 equals 3x plus 4. And then we just need to get x by itself. So I'm going to subtract 2x from both sides. 1 equals x plus 4. Then I need to subtract 4 from both sides. X equals -3.